Hello there, and welcome to Midnight Science. I'm so glad you're here. Maybe you've spent the day looking up, wondering about those shapes drifting overhead. Or maybe you just need something gentle to carry you into sleep. Either way, tonight is for you. There's nothing you need to do now. Just let yourself settle. Let the tension leave your shoulders. Let your breathing slow, and let your thoughts drift like clouds across an open sky. Tonight, we're floating through the world of clouds, not with urgency or hard science, but with curiosity and wonder. We'll explore how they form, why they glow, where they go, and what secrets they hold. Some facts might surprise you. Others might simply wash over you like mist, soft and forgettable. And that's okay too. If this gentle journey helps you rest, consider liking and subscribing. It helps others find their way here, one sleepy soul at a time. But for now, just breathe. Let your body sink deeper into comfort. And let's begin. Clouds are not made of air. When you look up at a cloud, it seems so light, so insubstantial, like it might vanish if you reached for it. But clouds aren't empty. They're not made of air at all. They're made of water, tiny droplets so small that millions could fit on the head of a pin. Each droplet forms when water vapor in the air cools and condenses around a microscopic particle, a speck of dust, salt, or pollen floating invisibly through the atmosphere. These particles are called condensation nuclei, and without them, clouds couldn't exist. The droplets are so light that they don't fall. Instead, they hover, suspended by gentle updrafts and the simple physics of size. A cloud, then, is water that has forgotten how to fall, hanging in the air, weightless and patient, until conditions change. It's not vapor, not quite liquid, but something in between. A collection of tiny spheres catching light, holding moisture, and drifting slowly across the sky. A cloud can weigh more than a jumbo jet. It's hard to imagine something so soft and airy having weight. But clouds are heavier than they appear. A single cumulus cloud, one of those puffy white clouds that drifts lazily on a summer afternoon, can weigh over 1 million pounds. That's more than a fully loaded Boeing 747. How is that possible? Because while each water droplet is incredibly small, there are billions upon billions of them gathered together. All that water adds up, and yet the cloud doesn't fall. It floats because the droplets are so tiny that air resistance and updrafts keep them aloft. The weight is distributed across such a vast volume that it seems to have none at all. So when you see a cloud overhead, remember you're looking at something massive, quiet, and impossibly suspended. A floating lake held by the invisible hands of the atmosphere. Clouds form when air rises and cools. The birth of a cloud is a gentle process, almost like breathing. Warm air near the ground absorbs moisture from oceans, lakes, rivers, and soil. As the sun heats the surface, this warm, moist air becomes lighter and begins to rise. The higher it goes, the cooler it becomes. And cool air can't hold as much moisture as warm air. Eventually, the air reaches a point where it's saturated, where it can't hold any more water vapor. This is called the dew point. When that happens, the vapor condenses into droplets, and a cloud is born. The altitude where this occurs is often visible as a flat base to the cloud, a line where the invisible becomes visible. Rising air, cooling, condensing. It's a cycle that happens constantly, all over the world, in silence. Clouds are not placed in the sky. They emerge from it, shaped by temperature, pressure, and the patient choreography of the atmosphere. There are 10 main types of clouds. For centuries, people looked up and saw only chaos. But in 1802, a British pharmacist named Luke Howard proposed a system for classifying clouds, and it changed everything. He gave them Latin names based on their shape and altitude. There are 3 basic forms: cumulus, which means heap, stratus, which means layer, and cirrus, which means curl. From these, 10 main types emerge: low clouds like cumulus and stratus, middle clouds like altocumulus and altostratus, high clouds like cirrus, cirrostratus, and cirrocumulus, and clouds that span multiple levels like nimbostratus and cumulonimbus. Each type tells a story about the atmosphere, about temperature, moisture, and motion. When you look up, you're not just seeing clouds. You're reading the sky, watching the invisible forces that shape weather, climate, and the mood of the day. These names are more than labels. They're a language, a way to speak with the heavens. Cirrus clouds are made of ice crystals high above the earth, where the air is thin and temperatures plunge far below freezing. Cirrus clouds form. These are the delicate, wispy clouds that stretch across the sky like brushstrokes. They don't look like typical clouds because they're not made of water droplets. They're made of ice. At altitudes above 20,000 feet, water vapor freezes directly into tiny ice crystals without ever becoming liquid. These crystals are thin, light, and shaped like needles or hexagons. They catch the sunlight and scatter it, giving cirrus clouds their white, fibrous appearance. Sometimes they glow with subtle colors at sunrise or sunset, painted in soft pinks and golds. Cirrus clouds rarely produce precipitation that reaches the ground. Instead, they signal changes in the weather, often appearing before a storm system arrives. They drift slowly, high and cold, untouched by the bustle below. Silent threads of frozen water floating at the edge of space. Fog is just a cloud touching the ground. There's something mysterious about fog. The way it rolls in silently, obscuring the familiar and turning the world into something soft and uncertain. But fog is not a separate phenomenon. It's simply a cloud that has formed at ground level. The process is the same. Air cools, moisture condenses, droplets form. The only difference is altitude. Fog can form in different ways. Radiation fog appears on clear, calm nights when the ground loses heat and cools the air just above it. Advection fog happens when warm, moist air moves over a cold surface, like the ocean. Valley fog settles into low areas where cold air sinks. Each type has its own character, but all are clouds, grounded and patient. Walking through fog is like stepping inside a cloud's quiet embrace. The air thickens, sounds soften. The world shrinks to just a few feet in any direction. And for a moment, you're part of the sky. Clouds can form in patterns called cloud streets. Sometimes, when conditions align, clouds don't scatter randomly across the sky. They organize themselves into long, parallel rows that stretch for miles, like streets laid out across the heavens. These are called cloud streets, and they form when wind blows in a consistent direction, while the air below is being heated unevenly. As warm air rises in columns, it cools and forms clouds. Between the columns, cooler air sinks, creating clear gaps. The result is a repeating pattern, row after row, visible from the ground or strikingly clear from space. Pilots flying through cloud streets report a rhythmic experience, alternating between shadow and sunlight as they pass through atmosphere has structure. That chaos can give way to order when the forces align. The sky, it turns out, has its own geometry. Mammatus clouds look like hanging pouches. Of all the cloud formations in the sky, few are as strange and mesmerizing as mammatus clouds. They appear as bulging, pouch-like structures hanging from the underside of a cloud, often after a severe thunderstorm. The name comes from the Latin word for udder, and the resemblance is unmistakable. These clouds form when cold air sinks into warmer air below, creating pockets of downward motion. The result is a lumpy, textured ceiling that can cover the entire sky. Mammatus clouds often glow in orange or pink light during sunset, adding to their otherworldly appearance. Despite their dramatic look, they're generally harmless and indicate that a storm is dissipating rather than intensifying. Still, seeing them is unforgettable. The sky seems to turn inside out, solid where it should be empty, hanging where it should float. A ceiling of softness, carved by the invisible currents of the air. Lenticular clouds look like UFOs high in the mountains. A strange phenomenon sometimes occurs. Smooth, lens-shaped clouds appear, stacked in layers, and hovering perfectly still even as wind rushes past them. These are lenticular clouds, and they've been mistaken for UFOs more times than anyone can count. They form when moist air flows over a mountain range, creating waves in the atmosphere, much like water flowing over rocks in a stream. At the crest of each wave, the air cools and condenses, forming a cloud. At the trough, it warms and evaporates. The cloud doesn't move because it's constantly forming on one side and dissolving on the other, like a stationary waterfall of vapor. Lenticular clouds are smooth, symmetrical, and often brilliantly white. They can appear alone or in stacks, hovering like discs above the peaks. Pilots avoid flying through them because the turbulence inside can be severe. But from the ground, they're simply beautiful, mysterious visitors from the invisible river of wind. Some clouds produce lightning without rain. Not all storms are wet. In certain conditions, clouds can generate lightning without producing any precipitation that reaches the ground. This happens most often with high-based thunderstorms in dry climates. The rain evaporates before it hits the surface, a process called virga. But the electrical charge within the cloud remains. When that charge becomes strong enough, it releases as lightning, illuminating the sky without the accompaniment of rain. These dry lightning storms are particularly dangerous because they can spark wildfires. A single bolt striking dry vegetation can ignite a blaze that spreads quickly, especially in arid regions. The sky flashes, the thunder rolls, but the ground stays dry. It's a reminder that clouds are not just water. They're energy, potential, and power wrapped in softness. Even without rain, they can still touch the earth. Clouds can travel thousands of miles. A cloud drifting lazily overhead may seem stationary, but it's on a journey. Clouds are carried by the wind, and depending on their altitude, they can move at vastly different speeds. Low clouds may drift at 10 to 20 miles per hour. High clouds, especially those in the jet stream, can race along at over 100 miles per hour. Over the course of days, a single cloud system can travel across continents or oceans, carrying moisture from one climate zone to another. Clouds formed over the Pacific Ocean can bring rain to California. Clouds from the Amazon can drift east and fall as precipitation over the Atlantic. In this way, clouds connect distant parts of the world, weaving the atmosphere into a single, flowing system. They don't belong to one place. They pass through, carrying stories written in vapor and ice, traveling until they dissolve or transform, returning their water to the earth below. Contrails are human-made clouds. Look up on a clear day, and you might see long white streaks trailing behind airplanes. These are contrails, short for condensation trails, and they're a type of cloud created by human activity. When a jet engine burns fuel, it releases water vapor along with other gases. At high altitudes, where the air is cold and thin, this vapor quickly condenses and freezes into tiny ice crystals, forming a visible trail. Sometimes contrails disappear within seconds. Other times, they linger and spread, forming thin sheets that can last for hours. Whether they persist depends on the humidity and temperature of the surrounding air. Scientists study contrails because they can affect climate, trapping heat and altering the amount of sunlight reaching the ground. They're a reminder that humans now leave their mark even in the sky, drawing lines across the blue, writing our presence in ice and vapor. Clouds reflect sunlight back into space. Clouds play a quiet but essential role in regulating Earth's temperature. Their white surfaces are highly reflective, bouncing a significant portion of the sun's energy back into space before it can warm the planet. This is called the albedo effect. Without clouds, Earth would absorb much more solar radiation, and surface temperatures would be far higher. On average, clouds reflect about 30% of incoming sunlight. The type of cloud matters. Thick, low clouds like stratus are particularly effective at reflecting light. High, thin clouds like cirrus let more light through and can even trap heat, acting as a blanket rather than a mirror. The balance between these effects is delicate and constantly shifting. Clouds cool the planet during the day and warm it at night. They're part of a complex feedback system that helps stabilize Earth's climate. Quiet, floating, and essential, they shield us from the sun's full intensity, giving us the gentle warmth we need to thrive. Storm clouds can tower over 10 miles high. On a hot summer afternoon, you might see them building on the horizon. Towering columns of cloud that rise higher and higher, swelling into massive structures that dwarf mountains. These are cumulonimbus clouds, the giants of the atmosphere. They can grow to heights of 40,000 feet or more, stretching from near the ground all the way to the edge of the stratosphere. Inside, powerful updrafts and downdrafts churn, lifting water droplets and ice crystals in violent cycles. This motion generates static electricity, which eventually discharges as lightning. Rain, hail, and sometimes tornadoes can emerge from these clouds. The top of a cumulonimbus often flattens into an anvil shape, spread wide by high-altitude winds. From below, they can look menacing, dark and heavy, but from above, astronauts and pilots have described them as beautiful, glowing white towers rising from a sea of smaller clouds. They are power and motion made visible, storms waiting to be born. Clouds can glow at night. Most clouds fade into darkness after sunset, but some continue to glow. Noctilucent clouds, also called night-shining clouds, are the highest clouds in Earth's atmosphere. They form at altitudes of around 50 miles, far above where normal clouds can exist. They're made of ice crystals that form around tiny particles, possibly from meteor dust. Because they're so high, they catch sunlight even after the sun has set below the horizon, glowing with a pale blue or silver light against the darkening sky. Noctilucent clouds are rare and usually visible only during summer at high latitudes. Places like Scandinavia, Canada, or Alaska. They appear as delicate rippling bands or waves, luminous and ethereal. Scientists believe they're becoming more common, possibly due to changes in the upper atmosphere linked to climate change. These glowing clouds are a reminder that even in the deep night, light finds a way to linger, shimmering softly at the edge of space. Morning glory clouds roll like waves across the sky. In a remote region of northern Australia, a rare and spectacular cloud formation appears almost every spring. It's called the morning glory cloud, and it looks like a giant rolling wave stretching across the sky. These clouds can be up to 600 miles long and move at speeds of 35 miles per hour, appearing as a series of parallel tubes that seem to roll forward like breaking surf. The exact mechanism that creates them isn't fully understood, but they're thought to form from sea breezes colliding over the Gulf of Carpentaria, creating waves in the lower atmosphere. Pilots and glider enthusiasts travel from around the world to ride these clouds, surfing the updrafts like invisible hills in the sky. From the ground, they're hypnotic, long and smooth, moving steadily across the horizon. The morning glory is a reminder that the atmosphere is full of motion, that air can flow and crash and roll just like water, and that some of the most beautiful phenomena happen in the places we least expect. Clouds help distribute heat around the planet. The Earth is unevenly heated. The equator receives more sunlight than the poles, creating temperature differences that could make the planet uninhabitable if left unchecked. But clouds, along with wind and ocean currents, help redistribute this heat. When warm, moist air rises near the tropics, it forms clouds and releases latent heat as the water vapor condenses. This heat warms the upper atmosphere and is carried toward the poles by global wind patterns. Meanwhile, clouds over cooler regions trap some of the Earth's outgoing heat, preventing it from escaping into space too quickly. This constant exchange moderates temperatures, preventing extreme heat at the equator and extreme cold at the poles. It's a planetary balancing act, and clouds are key players. They don't just float, they work quietly and continuously, smoothing out the differences, keeping the whole system in balance. Without them, Earth would be a very different, far less hospitable place. Some clouds never produce rain. Not every cloud is destined to become rain. Many clouds form, drift, and dissolve without ever releasing a single drop. Whether a cloud produces precipitation depends on several factors: the size of the water droplets, the temperature, the presence of ice crystals, and the movement of air. For rain to fall, droplets need to grow large enough that gravity can pull them down faster than updrafts can hold them up. This usually requires the droplets to collide and merge, a process called coalescence, or to freeze and grow around ice crystals in a process called the Bergeron process. In dry climates, even if rain begins to fall from a cloud, it may evaporate before reaching the ground, leaving only a faint veil beneath the cloud called virga. So a cloud may carry water across the sky for hours or even days, never releasing it, simply holding it aloft until the air warms and the droplets evaporate back into invisibility. Clouds are patient. They don't rush to give their water away. Kelvin Helmholtz clouds look like breaking waves. Sometimes the sky reveals the hidden dance of wind. Kelvin Helmholtz clouds appear as a series of perfect curling waves, like ocean surf frozen in mid-break. They form when two layers of air move at different speeds, creating shear between them. The faster layer flows over the slower one, and instability causes the boundary to roll into waves. The effect is most visible when the lower layer is moist enough to form clouds, while the upper layer remains clear. The result is a stunning display, row after row of curling crests that look almost too perfect to be real. These clouds are short-lived, usually lasting only a few minutes before the turbulence smooths them out. Pilots consider them a sign of strong wind shear and avoid flying through them. But from the ground, they're mesmerizing. A glimpse into the invisible rivers of air that flow above us, constantly shifting, layering, and folding in on themselves. Clouds are older than you think. The water molecules inside a cloud may have been cycling through the Earth systems for billions of years. The water you see in a cloud today might once have been part of an ancient ocean, a dinosaur's drink, a raindrop on a medieval roof, or a snowflake that fell on a glacier and melted centuries later. Water doesn't disappear. It transforms. It evaporates, condenses, freezes, melts, flows, and rises again in an endless cycle. A single molecule can travel from the ocean to the sky, to the soil, and back again countless times. In this way, clouds are not new. They're made of the oldest substance on the planet, constantly recycled, constantly renewed. When you watch a cloud drift by, you're seeing water that has witnessed the entire history of life on Earth. It has no memory, but it has been everywhere, and it will continue its journey long after we're gone. Clouds can form in layers that don't mix. Sometimes, when you look up, you'll see clouds at multiple levels, each moving in a different direction or remaining still while others race by. This happens because the atmosphere is stratified into layers, each with its own temperature, humidity, and wind speed. Low clouds might drift slowly from the west, while high clouds streak eastward in the jet stream. These layers don't mix easily. They're separated by stable boundaries where air doesn't rise or fall. It's like looking at different floors of a tall building, each with its own weather, its own rhythm. The clouds in each layer are independent, unaware of the others. This layering gives the sky depth and complexity, a reminder that the atmosphere is not a single thing, but a stack of invisible oceans, each with its own currents, each moving to its own unseen tune. Polar stratospheric clouds shimmer with rainbow colors in the coldest parts of the atmosphere. Above the poles in winter, rare and beautiful clouds can form. Polar stratospheric clouds, also called nacreous clouds or mother-of-pearl clouds, appear at altitudes of 50,000 to 80,000 feet, far higher than normal clouds. They're made of tiny ice crystals or supercooled droplets that scatter sunlight in a way that creates brilliant iridescent colors, shimmering bands of pink, green, blue, and violet. These clouds are most visible at twilight when the sun is below the horizon, but still illuminating the upper atmosphere. They look almost unreal, like auroras frozen into cloud form. Despite their beauty, polar stratospheric clouds play a troubling role in atmospheric chemistry. They provide surfaces where chemical reactions occur, reactions that lead to ozone depletion. In the quiet cold above the poles, these shimmering clouds contribute to the thinning of the ozone layer. Beauty and harm drifting together in the frozen sky. Clouds have been part of Earth for billions of years. As long as Earth has had liquid water and an atmosphere, it has had clouds. The first clouds likely formed not long after the planet's surface cooled enough for water vapor to condense. For much of Earth's early history, the sky would have looked very different. The atmosphere was thicker, filled with volcanic gases, and the clouds may have been darker, heavier, and more persistent. As life evolved and oxygen accumulated, the composition of the atmosphere changed, and so did the clouds. But the basic process has remained the same. Water evaporates, rises, cools, and condenses. Clouds have witnessed every era of Earth's history. They drifted over the first continents, over ancient oceans teeming with strange life, over the rise and fall of countless species. They watched the dinosaurs, the ice ages, the birth of forests and mountains, and they'll continue to form long after humanity is gone. Silent witnesses to a planet that breathes, cycles, and renews itself without pause. Some clouds form around pollution. Not all clouds are natural. In industrial areas and cities, pollution can seed the formation of clouds that wouldn't exist otherwise. Tiny particles from car exhaust, factory smokestacks, and burning fuel act as condensation nuclei, providing surfaces for water vapor to cling to. These human-made particles can make clouds thicker and longer lasting. They can also change the size of the droplets, making them smaller and more numerous, which affects how much sunlight the cloud reflects and whether it produces rain. This phenomenon has subtle but measurable effects on local weather and climate. In some cases, pollution-seeded clouds can suppress rainfall by creating too many small droplets that don't easily collide and grow. In others, they can enhance precipitation. The relationship is complex and still being studied, but it's clear that humans are not just observers of clouds. We're participants, shaping them in ways we're only beginning to understand. Clouds can form spirals in hurricanes. At the heart of a hurricane, clouds don't just gather randomly. They organize into a massive spiral, arms of clouds and rain that wrap around a calm center called the eye. This structure forms because of the Coriolis effect, the rotation of the Earth, which causes moving air to curve. As warm, moist air rises rapidly over the ocean, it feeds the storm, and the spinning motion pulls clouds into spiraling bands. From space, hurricanes look like enormous, slow-motion whirlpools of vapor, stretching hundreds of miles across. The eye itself is often clear, a column of descending air that suppresses cloud formation. Inside the eye, the sky can be blue and calm, while all around, the storm rages. These spirals are both beautiful and terrifying, a reminder that clouds are not passive. When conditions align, they can organize into systems of devastating power, spinning storms that reshape coastlines and lives. Clouds absorb and emit infrared radiation during the day. Clouds reflect sunlight, cooling the planet. But at night, they do the opposite. They trap heat. This happens because clouds absorb infrared radiation, the heat emitted by Earth's surface, and then radiate some of it back downward. It's like a blanket, not a perfect one, but enough to keep nighttime temperatures warmer than they would be under a clear sky. This is why cloudy nights tend to be milder than clear ones. The heat that would otherwise escape into space is held close, recirculated by the clouds above. This dual role, cooling by day and warming by night, makes clouds essential to Earth's energy balance. They moderate extremes, softening the temperature swings between day and night, summer and winter. In their quiet presence, they help keep the planet stable, livable, and gentle. There are clouds on other planets too. Earth is not the only world with clouds. Across the solar system, planets and moons have their own atmospheric phenomena, some eerily familiar, others utterly alien. Venus is shrouded in thick clouds of sulfuric acid that reflect so much sunlight, the planet glows brightly in our sky. Mars has thin clouds of water ice and carbon dioxide. Jupiter and Saturn have multi-layered cloud decks made of ammonia, water, and other compounds, swirling in bands and storms that dwarf anything on Earth. Titan, Saturn's largest moon, has clouds of methane that rain liquid hydrocarbons onto its surface. Even distant Neptune has bright, fleeting clouds made of methane ice. Each world's clouds tell a story about its atmosphere, its chemistry, its distance from the sun. They remind us that clouds are not unique to our blue planet. Wherever there's an atmosphere and the right conditions, clouds will form, drifting through alien skies, silent and strange. Clouds can create their own wind in the heart of a thunderstorm. Clouds don't just respond to wind, they create it. As rain begins to fall, it drags air downward with it, creating a downdraft. When this column of cold, dense air hits the ground, it spreads out in all directions, forming powerful gusts called outflow winds. These winds can race ahead of the storm, bending trees, kicking up dust, and dropping temperatures suddenly. Sometimes they're strong enough to cause damage on their own, even without a tornado. The leading edge of the outflow, where it meets warm, still air, is called a gust front. It can lift that warm air and feed it back into the storm, sustaining the system and sometimes triggering new storms. In this way, a cloud becomes a self-sustaining engine, pulling in energy, transforming it, and exhaling wind. The cloud breathes, and the world below feels its breath. The bottoms of clouds are usually flat. One of the most striking features of many clouds is their flat base. It looks almost unnatural, like the clouds have been pressed against an invisible ceiling. But there's a simple reason for this. Clouds form at a specific altitude where rising air reaches its dew point, the temperature at which it becomes saturated, and water vapor begins to condense. Below that altitude, the air is too warm and dry for condensation. Above it, clouds can grow upward into towers or spread sideways into layers, but the bottom remains fixed at the level where conditions first allowed the cloud to form. This creates that distinct level base. It's a visible line marking the boundary between the unseen and the seen, between vapor and droplet. The atmosphere has invisible layers, and clouds make them visible, painting a line in the sky that shows us where the air changes, where warmth gives way to coolness, and where water becomes cloud. Clouds can evaporate before your eyes. Sometimes a cloud that seems solid and enduring can vanish in minutes. This happens when the air around it warms or dries, causing the droplets to evaporate back into invisible vapor. You might watch a small cumulus cloud shrink and fade, its edges softening, its core thinning, until there's nothing left but blue sky. It didn't go anywhere exactly. It simply changed form, returning to the air from which it came. This constant cycle, forming and dissolving, is how clouds respond to the shifting conditions of the atmosphere. They are temporary gatherings of water, held together as long as the temperature and humidity allow. When those conditions change, the cloud lets go. There's something quietly poetic about it, the way clouds appear and disappear, never grasping, never resisting. They exist fully in the moment, and when the moment passes, they release without hesitation. Clouds are part of the water cycle. Every cloud is a traveler in a much larger journey, a story that begins in the ocean and returns there again and again. The water cycle is an endless movement of water through Earth systems, evaporation from oceans, lakes and rivers, condensation into clouds, precipitation as rain or snow, and runoff back into bodies of water. Clouds are the visible stage in this process, the moment when invisible vapor becomes something we can see and feel. They carry water from one place to another, lifting it high into the atmosphere, transporting it across continents, and releasing it where it's needed. Without this cycle, life as we know it couldn't exist. Fresh water wouldn't reach inland areas. Ecosystems would collapse. Clouds are not decorations. They're essential workers in the planet's plumbing, part of a system that has been running smoothly for billions of years, moving water, sustaining life, and shaping the surface of the world. Cloud seeding can make it rain. For decades, humans have experimented with ways to influence clouds, to coax rain from skies that seem reluctant to give it. The process is called cloud seeding, and it involves introducing substances like silver iodide or dry ice into clouds. These particles act as additional condensation nuclei, giving water vapor more surfaces to cling to. In the right conditions, this can encourage droplets to grow large enough to fall as rain. Cloud seeding doesn't create rain from nothing. It can only enhance precipitation in clouds that are already on the verge of producing it. The effectiveness varies, and there's still debate about how much difference it truly makes. Some regions use it during droughts or to increase snowpack in mountains. Others seed clouds before major events to prevent rain. It's a delicate intervention, an attempt to nudge nature in a particular direction. The clouds don't always cooperate, but sometimes, just sometimes, the sky opens and the rain falls where it's needed most. You can sometimes see the shadow of a cloud from inside it. If you've ever been in an airplane and flown through a cloud, you may have noticed something strange and beautiful. Looking down, you might see the shadow of your own plane surrounded by a circular rainbow called a glory. Or you might see the shadow of the cloud itself projected onto a lower layer of clouds or the ground below. These shadows can be sharp and defined or soft and diffuse, depending on the angle of the sun and the thickness of the cloud. It's a surreal experience, seeing the shape of something you're inside, rendered in darkness on the world below. The shadow moves as the cloud moves, drifting silently across fields, forests, and water. It's a reminder that clouds are not just light and air. They're solid enough to block the sun, dense enough to cast shadows, real enough to touch the earth with their presence, even from miles away. Clouds influence the color of the sky. The sky is blue because of the way sunlight scatters through the atmosphere, but clouds can change everything. Thick clouds block direct sunlight, making the sky beneath them grey or even dark. Thin clouds can diffuse light, creating a soft, even glow. At sunrise and sunset, clouds become canvases for colour, glowing in shades of orange, pink, red and purple as the sun's light passes through more of the atmosphere and reflects off the cloud surface. The exact colours depend on the cloud's altitude, thickness, and the angle of the light. High, thin clouds catch light long after the sun has set, glowing softly against the darkening sky. Low, thick clouds can appear almost black in contrast. Clouds don't just inhabit the sky, they paint it, adding texture, depth, and constantly shifting beauty to the view above. Some clouds last for days, while some clouds form and dissolve in minutes. Others can persist for days or even weeks. Large, stable weather systems can create expansive cloud decks that cover entire regions, moving slowly or remaining nearly stationary. These persistent clouds are often associated with low-pressure systems or marine layers, thick blankets of stratus clouds that form over cool ocean waters and drift inland. In some coastal areas, these clouds are a daily occurrence, rolling in each morning and burning off by afternoon, or lingering all day in cool, damp conditions. On a global scale, certain cloud formations can be tracked by satellite as they drift across oceans and continents. They grow, shrink, merge with others, and eventually dissipate, but their journey can span thousands of miles and many days. These long-lived clouds are reminders that the atmosphere moves slowly sometimes, that weather systems can settle in and linger, patient and unhurried, like visitors who aren't quite ready to leave. Clouds are essential to life on Earth. Without clouds, Earth would be unrecognizable. The planet would be hotter, drier, and far less hospitable. Clouds regulate temperature, distribute water, and protect us from the sun's harshest rays. They create rain that fills rivers, nourishes crops, and sustains ecosystems. They moderate the climate, preventing extreme heat during the day and extreme cold at night. Life has evolved in a world where clouds are constant, where the water cycle turns endlessly, where rain falls and seasons change. Remove clouds and the whole system collapses. Deserts would expand, forests would wither. The delicate balance that allows life to thrive would be lost. Clouds are not just beautiful or interesting, they're fundamental. Every drop of rain, every breeze, every sunrise filtered through mist, all of it depends on these floating gatherings of water. They are, in the truest sense, life givers, silent and tireless, drifting through the sky, holding the planet together. Clouds can predict the weather long before satellites and computer models. People read the clouds to know what was coming. Sailors, farmers, and travelers all learn to interpret the sky's messages. High, wispy cirrus clouds often signal that a weather system is approaching, usually within a day or two. Thickening and lowering clouds suggest rain is near. A ring around the moon caused by ice crystals in cirrostratus clouds often precedes a storm. Dark, towering cumulonimbus clouds mean thunderstorms are imminent. These aren't superstitions. They're observations based on atmospheric patterns that have held true for centuries. Modern meteorology has refined our understanding, but the basic principle remains. Clouds reveal what's happening in the atmosphere. They show us where air is rising, cooling, and condensing. They map invisible pressure systems and fronts. The sky is always speaking, always offering clues. All you need to do is look up and listen with your eyes. Thunderstorm clouds can generate electricity continuously inside a cumulonimbus cloud. A storm is brewing not just with wind and water, but with electricity. As ice particles and water droplets collide within the churning updrafts and downdrafts, they transfer electric charge. Lighter ice crystals, carried upward, become positively charged. Heavier particles, falling downward, accumulate negative charge. This separation creates an electric field strong enough to overcome the insulating properties of air. When it does, electricity flows in a brilliant flash we call lightning. But the charging doesn't stop. As long as the storm continues, the process repeats. Some storms produce lightning continuously for hours, flash after flash, illuminating the clouds from within. Thunder rolls, echoing across miles. The air smells of ozone. And high above, the cloud pulses with energy. A living battery powered by motion, temperature difference, and the restless energy of rising air. Clouds can create optical illusions. Sometimes the sky plays tricks on your eyes. Clouds, combined with light and perspective, can create illusions that seem impossible. Pareidolia, the tendency to see familiar shapes in random patterns, makes us see faces, animals, or objects in cloud formations. But there are real optical effects too. A sundog, or parhelion, appears as a bright spot of light on either side of the sun, caused by ice crystals in cirrus clouds refracting sunlight at specific angles. A circumhorizontal arc, sometimes called a fire rainbow, forms when sunlight passes through ice crystals in high clouds, creating a horizontal band of rainbow colors. Cloud iridescence produces soft pastel colors along the edges of clouds. These aren't imagined. They're physics, light bending and splitting through ice and water in ways that create beauty we never expected. The sky becomes a prism, a kaleidoscope, a stage for colors that shouldn't exist but do. Low clouds can hug mountains and valleys. In mountainous regions, clouds often settle into valleys or wrap around peaks like scarves. These are orographic clouds, formed when moist air is forced to rise over terrain. As the air climbs, it cools and condenses, creating clouds that cling to the landscape. Sometimes a single mountain will wear a cap cloud, a lens-shaped formation that hovers just above the summit. Other times, fog fills entire valleys, transforming them into seas of white with only the highest peaks visible above. These clouds can last for hours or days, especially in coastal mountains where moist ocean air constantly flows inland. From above, the scene is surreal, a landscape half hidden, half revealed, where solid earth and soft vapor merge. The mountains breathe clouds, drawing them in, holding them close, and eventually releasing them as the day warms and the air shifts. Cloud droplets are incredibly small. The water droplets that make up clouds are almost unimaginably tiny. A typical cloud droplet measures about 10 to 20 micrometers in diameter. That's roughly 1/10 the width of a human hair. At this scale, they're too small to see individually. What we perceive as a cloud is the collective effect of billions upon billions of these droplets scattering light. Because they're so small, they fall incredibly slowly. In still air, a cloud droplet would take hours to descend just a few hundred feet. But the air is rarely still. Updrafts easily overpower gravity, keeping the droplets aloft, suspended in a delicate balance. Only when droplets collide and merge, growing larger, do they become heavy enough to fall as rain. Until then, they hover, lighter than dust, drifting in the invisible currents, part of something vast, but individually almost nothing at all. Some clouds glow from within during storms. At night, during a thunderstorm, you might see something extraordinary. The clouds themselves seem to glow, pulsing with light from inside. This is lightning illuminating the cloud from within, called sheet lightning or intra-cloud lightning. The bolt travels between different charged regions within the same cloud, never reaching the ground. From outside, you don't see the bolt itself, just the sudden brightening of the entire cloud mass, as if someone briefly turned on a lamp inside a paper lantern. The effect can be mesmerizing, especially when the lightning flashes rapidly, creating a strobe-like pulse across the night sky. The cloud becomes a luminous shape, its internal structure briefly visible, towers and caverns and billowing forms revealed for an instant before darkness returns. It's a reminder that clouds are not solid, not simple. They're volumes, three-dimensional spaces filled with motion and energy, occasionally lit from within by the spark of a storm. Ancient cultures worshipped cloud gods. Humans have always looked to the sky with wonder and reverence. Many ancient cultures believed clouds were divine, controlled by gods or spirits. In Greek mythology, Zeus commanded the sky and its weather from Mount Olympus. The Aztecs worshipped Tlaloc, the god of rain and storms, whose tears fell as life-giving water. In Hindu tradition, Indra rides a white elephant through storm clouds, wielding lightning as his weapon. Native American tribes across North America had countless stories of cloud beings, thunderbirds, and sky spirits who shaped the weather and influenced human fate. These weren't just stories. They were explanations for forces beyond human control, attempts to understand why rain came or didn't come, why storms destroyed or spared, why the sky could be gentle one day and violent the next. Clouds represented mystery, power, and the connection between earth and heavens. In every culture, people saw the sacred written in vapor. Clouds move in rivers of air called jet streams. High above the weather we experience on the ground, narrow bands of fast-moving air snake around the globe. These are jet streams, and they guide clouds on long journeys across continents and oceans. The polar jet stream, flowing at altitudes of 30,000 to 40,000 feet, marks the boundary between cold polar air and warmer air to the south. Wind speeds within the jet stream can exceed 200 miles per hour. Clouds caught in these currents race eastward, crossing time zones in hours. Pilots use jet streams to save fuel and time when flying in the same direction, and avoid them when flying against the flow. Weather systems follow these invisible highways too, which is why storms often move along predictable paths. The jet stream is constantly shifting, meandering north and south in waves, creating patterns that influence weather for weeks at a time. Clouds riding these currents are travelers on an express route, carried by winds most of us never feel. Some clouds form from wildfire smoke. Where there's fire, there's often cloud. Wildfires generate enormous amounts of heat, which creates powerful updrafts. As hot air rises from the flames, it carries smoke, ash, and moisture high into the atmosphere. If conditions are right, this rising air cools and condenses, forming a cloud directly above the fire. These are called pyrocumulus clouds, or fire clouds. In extreme cases, they can develop into full thunderstorms, called pyrocumulonimbus, complete with lightning, rain, and strong winds. Ironically, the rain rarely reaches the ground. It evaporates in the hot, dry air below. But the lightning these clouds produce can spark new fires, creating a dangerous feedback loop. Fire clouds are dark, ominous, and chaotic, towering above the flames like monuments to destruction. Yet they're still clouds, still made of water, still following the same physical processes. Even in chaos, the atmosphere creates order, lifting heat and moisture skyward, transforming fire into vapor. Cloud cover affects how stars appear. On a cloudy night, the stars disappear. Even a thin layer of clouds can block starlight, turning the sky into a blank grey ceiling. But the type of cloud matters. Thick, low clouds like stratus or cumulus block nearly all light, leaving the night dark and closed. High, thin cirrus clouds made of ice crystals can create halos around the moon, or make stars appear to shimmer and twinkle more than usual. The ice crystals act like tiny prisms, bending and scattering light. In areas with light pollution, clouds can make the problem worse, reflecting artificial light back down and creating an orange or pink glow that drowns out even the brightest stars. But in remote areas, breaking clouds can create a magical effect, framing the stars, revealing them in patches, then hiding them again. The sky becomes a shifting window, opening and closing, offering glimpses of the cosmos beyond. Clouds influence how quickly glaciers melt. In the high mountains and polar regions, glaciers are locked in a slow dance with the atmosphere, and clouds play a key role. Low clouds can shade glaciers from direct sunlight, slowing melting during warm months. But clouds also trap heat, especially at night, preventing cold air from settling and refreezing meltwater. The balance between these effects determines how quickly a glacier gains or loses mass over time. In recent decades, as global temperatures have risen, cloud patterns have shifted, altering this balance. Some glaciers are retreating faster than predicted, partly because of changes in cloud cover. Scientists study these interactions carefully, using satellites and ground sensors to track both clouds and ice. It's a reminder that nothing in the climate system exists in isolation. Clouds, ice, ocean, and air are all connected, each influencing the others in complex, sometimes surprising ways. Airplane wings can create clouds. When conditions are just right, you can actually see clouds forming off the wings of an airplane. This happens when the plane flies through moist air, and the wing's shape causes a sudden drop in air pressure. Lower pressure means lower temperature, and if the air is close to its dew point, that cooling is enough to trigger condensation. Tiny clouds form at the wingtips or along the top surface, trailing behind like vapor ribbons. They disappear almost instantly as the air pressure normalizes, but for a moment, the plane wears clouds like wings of its own. Fighter jets performing high-speed maneuvers can create even more dramatic effects, surrounding themselves in cones of vapor during sudden turns or when breaking the sound barrier. It's a visible reminder that air is a fluid, that it can be shaped and sculpted by motion, and that even invisible forces can leave temporary, beautiful marks on the sky. Clouds can trap sounds and redirect them. Sound travels differently through cloudy air than through clear skies. Clouds affect both temperature and humidity, which change the speed of sound waves. In some cases, clouds can create temperature inversions where warm air sits above cool air, bending sound waves downward and making distant sounds seem closer and louder than they should be. Foggy or cloudy conditions can also muffle sounds, absorbing frequencies and making the world feel quieter, more intimate. Thunder sounds different depending on cloud structure. A cloud-to-ground lightning strike produces a sharp crack, followed by rumbling as the sound echoes through cloud layers. Distant thunder can seem to roll endlessly, bouncing between cloud and ground. In mountainous areas, clouds trapped in valleys can create acoustic effects, amplifying or distorting sounds in unexpected ways. The sky is not just a visual space, it's acoustic too, shaped by the presence or absence of clouds. Clouds form at different speeds. Some clouds appear suddenly, as if conjured from nowhere. Others take hours to build, growing incrementally until they dominate the sky. The speed of formation depends on atmospheric conditions. When warm, moist air encounters a strong lifting mechanism, like a mountain slope or a weather front, clouds can form in minutes. You can watch them materialize, thickening and spreading as you stand there. Other times, the process is slow and subtle. Thin wisps gradually coalesce. Scattered patches merge. A haze becomes a layer becomes a blanket. Time-lapse photography reveals just how dynamic this process is, showing clouds boiling upward, spreading, colliding, and dissolving in choreographed sequences that our eyes miss in real time. Clouds are not static paintings. They're processes, flows captured temporarily in visible form, always becoming, always shifting, never quite the same from one moment to the next. Ice clouds can fall as virga without melting. Virga is one of the most haunting sights in meteorology. Streaks of rain or snow falling from a cloud, but evaporating before reaching the ground. It appears as grey or white curtains hanging beneath the cloud base, slowly fading as they descend. In the case of ice virga, snow or ice crystals fall from high, cold clouds, but encounter warmer, drier air below. They sublimate, turning directly from solid to gas without melting. The result is a ghost of precipitation, rain that never arrives, snow that vanishes mid-flight. It's common in deserts and high-altitude regions, where the air near the surface is extremely dry. From the ground, you watch the cloud trying to give water, see the streaks descending, and yet feel nothing, no coolness, no wetness. The atmosphere drinks the moisture before it can reach you, patient and insatiable. Clouds change color based on thickness. Not all clouds are white. Their color depends on how thick they are and how much light can pass through them. Thin clouds allow sunlight to penetrate, appearing bright white or even translucent. As clouds grow thicker, they scatter more light, and less makes it through. The bottom of the cloud starts to look grey. Very thick clouds, like cumulonimbus, can appear almost black, especially when viewed from below in the shadow of the storm. But it's still water and ice. The darkness comes from absence of light, not from the cloud itself. From above, even the darkest storm cloud is brilliant white, its top reflecting sunlight just like any other. Sunset and sunrise add another dimension. Bathe in clouds in gold, orange, pink, and red as the sun's light passes through more atmosphere and reflects off the cloud surfaces at low angles. Clouds don't change what they are. They just reveal themselves differently depending on light and perspective. Sailors use clouds to navigate before GPS, before compasses pointed true north. Sailors read the sky for guidance. Certain cloud patterns could reveal the location of land long before it was visible. Stationary clouds that formed over islands caused by rising air over warm land could be seen from many miles away. Greenish tinges on the underside of clouds might reflect shallow lagoons. Darker patches could indicate deep water or openness beyond. Experienced navigators in the Pacific and Indian Oceans learn to interpret these subtle signs, combining them with knowledge of stars, currents, and bird behavior. Clouds became maps written daily across the sky, changing but readable. This knowledge, passed down through generations, allowed journeys across vast stretches of ocean with remarkable accuracy. Even today, when technology fails or in remote areas, the ancient skill of reading clouds can still guide a traveler home. The sky remembers the old ways. Clouds can grow vertically for miles in minutes. On a hot, unstable afternoon, watch the sky and you might witness one of the atmosphere's most impressive displays. A cumulus cloud, starting small and innocent, begins to tower. Within minutes, it surges upward, doubling in height, then doubling again. The top boils and churns, pushing higher as strong updrafts carry moisture into cooler air. In half an hour, a small puff can become a towering giant, reaching 40,000 feet or more. This explosive growth happens when atmospheric conditions are just right: warm, moist air at the surface and cold air aloft, creating instability. The rising air accelerates as it goes, powered by the release of latent heat as water vapor condenses. It's like watching a slow-motion explosion, a pillar of cloud climbing toward the stratosphere, fed by energy drawn from the sun-warmed earth below. Eventually, the storm matures. The updraft weakens and the cloud stops growing. But for a brief window, it seems unstoppable. Some clouds never see the sun deep in the polar winter, where night lasts for months. Clouds form and drift in total darkness. These clouds exist without sunlight, illuminated only by moonlight, stars, or the auroras that sometimes dance overhead. They're colder than almost any cloud elsewhere on Earth, formed in air so frigid that even ice struggles to exist. They move slowly through the endless night, invisible except when they block starlight or catch the faint glow of lunar reflection. Scientists study these polar clouds using satellites equipped with infrared sensors, watching their movements and evolution in wavelengths our eyes can't see. When spring finally arrives and the sun returns, these clouds don't disappear. They adjust, warming slightly, changing structure, but continuing their existence in the gradually brightening sky. They've known only darkness for months, and now, slowly, they begin to glow. Clouds contain tiny living organisms. Clouds are not sterile. High above the ground, far from soil and vegetation, bacteria and fungi drift through the air, swept up by wind and carried into the clouds themselves. These microorganisms don't just survive there. Some may actively influence cloud formation. Certain bacteria can act as ice nuclei, particles around which water freezes more easily. They might help trigger precipitation, allowing clouds to form rain or snow at higher temperatures than they otherwise would. It's a strange frontier of science, the intersection of biology and meteorology. How much do these tiny organisms affect weather? Are they passengers or active participants? Research is ongoing, but one thing is clear. Clouds are more than physics and chemistry. They're habitats, however temporary and harsh, where microscopic life drifts, suspended between Earth and space. Clouds can be classified by altitude alone. While we often think of clouds by their shape, altitude is equally important. Clouds are grouped into three main levels: low, middle, and high. Low clouds from the surface to about 6,500 feet include stratus, cumulus, and stratocumulus. These are the clouds of fog, drizzle, and gentle overcast skies. Middle clouds between 6,500 and 20,000 feet include altocumulus and altostratus. They're often grey or white layers that signal changing weather. High clouds above 20,000 feet are the ice clouds. cirrus, cirrostratus, and cirrocumulus. Delicate and thin, they exist in the coldest reaches of the troposphere. A few clouds span multiple levels, like nimbostratus and the towering cumulonimbus. This vertical classification reflects the different atmospheric conditions at each height, temperature, pressure, and moisture, all varying with altitude. The sky is not one place but many, stacked atop each other, each with its own character and clouds to match. Cloud droplets can stay liquid below freezing. Logic suggests that water freezes at 32 degrees, but cloud droplets often defy this rule. They can remain liquid at temperatures well below freezing, sometimes as cold as 40 degrees. These are called supercooled droplets, and they exist in a precarious state. Without something to trigger freezing, like dust or ice crystals, the water stays liquid despite the cold. But touch them, and they freeze instantly. Aircraft flying through clouds containing supercooled droplets can accumulate ice on their wings and fuselage, a dangerous condition called icing. The droplets hit the plane's surface and freeze on contact, building up layers of ice that add weight and disrupt airflow. Supercooled droplets are also key to many precipitation processes. When they encounter ice crystals in mixed-phase clouds, they freeze onto them, helping snowflakes grow. It's a delicate balance, water that should be ice but isn't, waiting for the right trigger to make the transformation. Clouds remember the landscape below. In subtle ways, clouds reflect what lies beneath them. Over cities, the heat island effect and pollution create more condensation nuclei, leading to different cloud patterns than over rural areas. Over forests, trees release organic compounds that seed cloud formation. Over oceans, sea salt provides abundant nuclei, creating marine clouds with distinct properties. Even the color of the ground matters. Dark surfaces absorb more heat, creating stronger updrafts that influence cloud development. Light surfaces reflect more sunlight, keeping the air cooler. These effects are small but measurable. Satellites can sometimes identify the type of surface below just by analyzing cloud characteristics. In this way, clouds become a mirror, however imperfect, reflecting the Earth's surface in vapor and moisture, carrying the signature of land and sea into the sky. Some clouds form only at night. While most clouds are driven by daytime heating, some prefer the darkness. Nocturnal clouds can form when the ground radiates heat away into space, cooling rapidly under clear skies. This cooling can create a temperature inversion, where the air near the surface becomes colder than the air above. If moisture is present, fog or low stratus clouds develop, blanketing the ground by morning. In other cases, nighttime clouds form over warm ocean waters when the air above cools, but the water stays warm, creating instability. Thunderstorms can also intensify at night in certain regions, particularly over land where daytime heating has primed the atmosphere, but the timing of maximum instability comes hours later. These nocturnal clouds are quieter, less dramatic than their daytime cousins, but they follow the same principles. They wait for the right conditions, and when darkness provides them, they appear. Clouds can make rainbows without rain. We usually associate rainbows with rain, but they can appear in clouds too. When sunlight passes through cloud droplets at the right angle, it bends and splits into colors, creating a rainbow effect on the cloud itself. These are called cloud bows or fog bows, and they're often paler than traditional rainbows, sometimes appearing almost white with just faint hints of color. The droplets in clouds and fog are smaller than raindrops, which changes how light scatters. Another phenomenon, the glory, appears as concentric colored rings around the shadow of an observer, often seen from airplanes looking down at clouds below. Each of these optical effects is a reminder that color doesn't need paint or pigment. It emerges from the interaction of light and water, physics creating beauty without intention, simply because the conditions allow it. The clouds don't know they're making rainbows. They just exist, and the light does the rest. Clouds connect the surface to the upper atmosphere. The atmosphere is not a single layer, but a vertical stack of zones with different properties. Clouds bridge these zones, physically connecting the ground to altitudes miles above. When air rises from the surface, it carries heat, moisture, and momentum upward, feeding clouds that redistribute these properties across the atmosphere. Deep convective clouds like cumulonimbus can transport air from near the ground all the way to the tropopause, the boundary between the troposphere and stratosphere. In doing so, they move energy, chemicals, and even living organisms vertically through the atmosphere. This mixing is essential for weather, climate, and air quality. Without clouds, the atmosphere would be more stratified, with less exchange between layers. Clouds are elevators, highways, and conduits, constantly moving matter and energy up and down, keeping the atmosphere well mixed and dynamic. Ancient ice cores record ancient clouds. Scientists who drill deep into ice sheets in Antarctica and Greenland are reading a history written in frozen water. Some of that water fell from clouds tens of thousands, or even hundreds of thousands of years ago. Trapped within the ice are tiny air bubbles, preserving samples of the ancient atmosphere. By analyzing the chemical composition of the ice and the gases in the bubbles, scientists can reconstruct past temperatures, atmospheric conditions, and even details about ancient cloud cover and precipitation patterns. Different isotopes of oxygen in the water reveal whether it came from warm or cold clouds. Dust particles trapped in the ice tell stories of ancient storms and winds. In this way, clouds from the distant past speak to us, their moisture preserved, their secrets slowly revealed layer by layer as researchers carefully peel back time frozen in ice. Clouds influence how much solar energy reaches Earth. Every day, clouds make a critical decision about how much of the sun's energy reaches the surface. On average, Earth receives about 70% of the solar energy that arrives at the top of the atmosphere. The rest is reflected back to space or absorbed by the atmosphere itself. Clouds are responsible for much of this regulation. They reflect sunlight, especially thick, low clouds with high albedo. But they also absorb some energy and re-radiate it downward as infrared heat. The net effect depends on cloud type, altitude, thickness, and time of day. Climate models spend enormous computational resources trying to accurately represent clouds because small changes in cloud cover or properties can significantly affect global temperatures. Clouds are not passive. They're active participants in Earth's energy budget, dials that adjust how much sunlight warms the planet and how much escapes into space. Some clouds are invisible to the naked eye. Not all clouds appear white and fluffy in the sky. Some exist beyond the range of human vision. High-altitude noctilucent clouds, for example, are best seen at twilight, when the sun illuminates them from below the horizon. During the day, they're often invisible against the bright sky. Other clouds are transparent or nearly so, thin layers of ice crystals or water droplets that don't scatter enough light to appear solid. They might reveal themselves only as a slight haze or by creating halos around the sun or moon. Infrared satellites can detect clouds that are completely invisible to us, thin sheets of moisture drifting at high altitudes. The sky contains more clouds than we see. Layers upon layers of moisture informs too subtle or too high for our eyes to register. We see only what our vision allows, but the clouds are there nonetheless, filling spaces we think are empty. Clouds can linger in the same spot for hours. While most clouds drift with the wind, some stay put. Orographic clouds, formed by air flowing over mountains, remain fixed in place even as the air moves through them. The cloud forms on the windward side where air rises and cools, and it dissolves on the leeward side where air descends and warms. The cloud appears stationary, but it's actually being continuously created and destroyed. New droplets forming on one side while old droplets evaporate on the other. It's like a waterfall that doesn't move, a standing wave of cloud held in place by terrain. These stationary clouds can last for hours or even days if wind conditions remain steady. They become landmarks, familiar features in the sky above certain peaks or ridges, always on the same place, always the same shape, yet never quite the same cloud. Clouds are part of Earth's carbon cycle. Water isn't the only thing clouds transport. They also play a role in moving carbon through the atmosphere. Rain falling from clouds absorbs carbon dioxide as it descends, forming weak carbonic acid. When this rainwater reaches the ground, it can dissolve minerals in rocks and soil, releasing ions that eventually flow into rivers and oceans. There, some of that carbon is taken up by marine organisms and locked away in shells and sediments, a process that removes CO2 from the atmosphere over long timescales. Clouds also influence photosynthesis. Overcast skies diffuse sunlight, sometimes allowing plants to photosynthesize more efficiently than under direct sun. Conversely, too many clouds can reduce overall light and limit plant growth. The relationship is complex, but it's clear that clouds are threads in the larger tapestry of Earth's carbon cycle, influencing how carbon moves between air, water, land, and life. You're always underneath some cloud somewhere. Even on the clearest day, clouds exist somewhere above you, just beyond your horizon, or at altitudes too high to see easily. The atmosphere is rarely completely clear. There's almost always moisture condensing somewhere, forming clouds that drift, build, and fade. Global satellite imagery shows that at any given moment, about 60% of Earth's surface is covered by clouds. They shift and swirl in vast patterns, spirals of storms, banks of marine stratus, scattered cumulus over continents. From space, Earth doesn't look like a blue marble. It looks like a blue and white marble, swirled with clouds that never stop moving. You may look up and see only blue, but elsewhere, above other lands and seas, clouds are gathering. The sky is never truly empty. It's always holding water, always preparing for the next rain, the next fog, the next soft veil drawn across the sun. Clouds have inspired art for millennia, from cave paintings to Renaissance masterpieces to modern photography. Clouds have captivated artists across time. They represent change, mystery, divine presence, and the sublime beauty of nature. Painters like John Constable dedicated entire studies to cloud formations, trying to capture their shapes, colours, and the quality of light they produced. Constable called the sky the chief organ of sentiment in a landscape. In Japanese art, clouds appear in woodblock prints, often stylized into flowing curves and spirals. In literature and poetry, clouds are metaphors for thought, emotion, impermanence. They drift through our creative consciousness as powerfully as they drift through the sky. Because clouds are always changing, they're endlessly interesting. No two cloudscapes are the same. Each moment offers something new, a fresh arrangement of light, shadow, and form that artists have tried to capture for as long as humans have made marks on surfaces. Clouds can exist on planets without water. While Earth's clouds are made of water, clouds on other worlds can be made of very different substances. On Venus, clouds are sulfuric acid droplets, part of a dense, toxic atmosphere that creates a runaway greenhouse effect. Jupiter's clouds contain ammonia, water, and complex organic compounds, creating bands of color that swirl in the planet's powerful winds. Titan, Saturn's moon, has clouds of liquid methane that rain onto the surface, filling lakes and seas with hydrocarbons. Even planets outside our solar system, exoplanets orbiting distant stars, may have clouds of iron droplets, molten glass, or vaporized rock. The concept of a cloud is universal, something condensed from a gas into liquid or solid particles that float in an atmosphere. But the substance varies wildly. Water is just one possibility, and on Earth, we're fortunate that our clouds are made of something so essential to life. The study of clouds has its own science. Nephology is a branch of meteorology dedicated to the study of clouds. It encompasses their formation, classification, dynamics, and role in weather and climate. Nephologists use satellites, radar, aircraft, and ground-based instruments to observe clouds in all their complexity. They build computer models to simulate cloud behavior and predict how clouds will respond to changing atmospheric conditions. It's a challenging field because clouds operate across a huge range of scales, from tiny droplets to massive storm systems spanning hundreds of miles. They involve processes from microphysics to planetary dynamics. Despite centuries of study, clouds still hold mysteries. How do certain types form? Why do some storms intensify while others weaken? How will clouds change in a warming world? These questions keep nephologists working, watching the sky, measuring the invisible, trying to understand the floating mysteries that pass overhead every day. Clouds make the sky feel infinite. There's something about clouds that opens the mind to vastness. They exist in 3 dimensions, layered at different altitudes, extending to the horizon and beyond. When you look at clouds, you're seeing depth, distance, and space in a way that a clear blue sky doesn't always convey. The shadows on a cloud's underside hint at its thickness. The way clouds overlap suggests their positions in space. On days when clouds fill the sky at multiple levels, the atmosphere becomes a visible volume, not a flat ceiling, but a realm with structure and form. This 3-dimensionality reminds us that the sky isn't a surface. It's a space, vast and full, stretching miles above and extending in all directions. Clouds populate that space, giving it texture and presence. They make the invisible visible, turning empty air into a landscape of light and shadow, near and far, here and beyond. Clouds will outlast us long after humans are gone. Clouds will still form. They've existed for billions of years. Since Earth's early atmosphere first had liquid water and enough cooling to allow condensation. They'll continue as long as there's an atmosphere, an ocean, and a sun to provide energy. Clouds are not dependent on us. They're part of a system far older and far larger than human civilization. They've watched continents drift, species rise and fall, ice ages come and go. They'll witness whatever comes next, indifferent and patient. In this sense, clouds are eternal, not as individuals, but as a process. Each cloud is temporary, a brief gathering of droplets that soon dissolves. But the cycle continues. Evaporation, condensation, precipitation, over and over, as long as the planet turns. We're privileged to share this moment with them, to see them drift past, to feel the rain they bring, to sleep beneath their softening of the stars. And now, let the clouds carry you to sleep. We've drifted together through a sky full of wonders, from the smallest droplet to the largest storm, from ancient myths to modern science. We've seen clouds that glow, clouds that freeze, clouds that span continents, and clouds that vanish in moments. We've learned that clouds are water, ice, and air, but also light, energy, and time. They're ancient and new, simple and complex, fragile and powerful. As you lie here now, perhaps you can imagine a cloud drifting slowly overhead. It has no urgency, no destination. It simply moves where the wind takes it, changing shape as it goes, growing here, fading there, always becoming something slightly different. That cloud is made of water that has traveled the world, that has fallen as rain in distant lands, flowed through rivers, rested in oceans, risen again as vapor, and now floats peacefully through the evening sky. You are beneath it, safe and still. The cloud asks nothing of you. It doesn't need to be understood or explained. It simply exists, soft and patient, a temporary gathering of moisture that will soon return to the air, only to form again somewhere else, sometime later. This is the way of clouds. They come and go. They hold and release. They appear and dissolve without resistance, without attachment. Let your thoughts do the same. Let them drift like clouds across the vast open sky of your mind. Some thoughts are light and wispy, like cirrus. Others are heavier, darker, like storm clouds. But all of them are temporary. All of them will pass. You don't need to hold them or push them away. Just watch them move across your inner sky, gentle and slow, fading at the edges, dissolving into nothing. Your breath is like the wind that carries clouds, slow and steady, in and out, a rhythm as old as the atmosphere itself. With each exhale, you release a little more tension, a little more weight. With each inhale, you draw in calm, cool air, fresh and renewing, breathing like the earth breathes, through forests and oceans, through clouds and rain, in cycles that never end. The world outside continues. Somewhere, clouds are forming over a distant ocean. Somewhere else, rain is falling on a quiet forest. In another place, fog is rolling through a valley, wrapping the trees in softness. The water cycle turns, patient and endless, connecting every part of the planet in a flow that has continued for billions of years and will continue long after tonight, long after this moment. You are part of that cycle. The water in your body has been cloud and rain, river and sea, ice and vapor. You carry the memory of ancient clouds within you, even if you don't remember. Every cell holds water that once floated freely in the sky, caught the sunlight, traveled with the wind. You are made of the same substance as clouds, shaped differently but fundamentally the same. Water, held temporarily in form, moving through a journey that has no beginning and no end. Let that thought comfort you. You're not separate from the sky, from the clouds, from the rain. You're part of it all, woven into the same fabric, subject to the same gentle laws. Just as clouds form and dissolve, so do thoughts, feelings, days, and years. Nothing is permanent, and that's not sad. It's peaceful. It means you can let go. It means you don't have to hold on so tightly. The clouds don't worry about tomorrow. They don't regret yesterday. They exist fully in this moment, drifting, changing, being exactly what they are. And right now, you can do the same. You don't need to be anything other than what you are in this moment. Tired, perhaps. Quiet, certainly. Ready for rest. Ready for sleep. Imagine yourself floating now, weightless as a cloud. You're suspended in soft air, held gently by forces you don't need to understand. There's no effort required. You simply rest, supported completely, drifting slowly through a peaceful sky. Below you, the world grows distant. Above you, stars begin to appear, tiny points of light in the deepening blue. The temperature is perfect, neither hot nor cold. The air around you is still, or perhaps moving just slightly, a whisper of wind that rocks you gently like a cradle. You have no weight here, no heaviness, no burden. You're as light as vapor, as soft as mist. You're dissolving at the edges, becoming part of the evening air, blending into the atmosphere like a cloud that has decided to let go. And it's safe to let go. The earth will keep turning. The water cycle will continue. Clouds will form and rain will fall and rivers will flow to the sea. The sun will rise tomorrow and warm the ground, and new clouds will gather in the afternoon sky. All of this will happen without your effort, without your attention. The world knows what to do, and so does your body. Your body knows how to rest. It knows how to repair and renew itself while you sleep. It knows how to slow your heartbeat, soften your breathing, release the tension in your muscles. You don't have to instruct it. You just have to allow it. The way a cloud allows itself to form when the conditions are right, without force, without struggle. Feel the softness beneath you, supporting you completely. Feel the weight of your body sinking down, settling in, finding its natural resting place. Your shoulders relax, your jaw unclenches, your hands open, palms up, releasing whatever they've been holding. Your feet grow heavy and still. Each part of you, from head to toe, surrenders to gravity, to comfort, to the gentle pull of sleep. The clouds above continue their slow drift. Some have caught the last light of sunset, glowing soft pink and gold at their edges. Others have faded to grey, blending into the darkening sky. A few stars have appeared between them, quiet and steady. The moon rises, casting silver light across the cloud tops, turning them luminous. From here, from this place of deep rest, you can see it all. Not with your eyes, which have grown heavy and closed, but with your mind's eye, calm and clear. You see the vastness of the sky, the endless motion of air and water, the patience of clouds that have drifted for millions of years and will drift for millions more. You see yourself as part of that vastness, a small but essential piece of something beautiful and infinite. There's nothing you need to do, nothing you need to solve or understand. The questions can wait, the worries can wait, everything can wait except this: rest, sleep, the deep, renewing darkness that comes when you finally let go and allow yourself to drift away. So drift now. Let the last threads of waking thought dissolve like a cloud in warm air. Let the images soften and blur. Let sounds fade to distant murmurs. Then to silence. Let your body become heavy and your mind become light. Let the boundary between you and the world grow thin and permeable until you're not sure where you end and the peace begins. You're floating in a sky of softness. You're cradled in cool air. You're dissolving into sleep the way a cloud dissolves into evening, gently and completely, leaving only tranquility behind. The night is here now, full and deep. The clouds have darkened to shadows. The stars have multiplied, filling the gaps with ancient light. And somewhere far above, invisible and patient, thin sheets of ice crystals catch the moonlight and shimmer, knock to loosen clouds at the edge of space, glowing softly in the darkness. You don't need to see them to know they're there. You don't need to understand them to feel their presence. They exist in a realm beyond your reach, beautiful and distant, doing what clouds have always done, gathering moisture, reflecting light, moving with the wind, being exactly what they are meant to be. And you too are exactly where you're meant to be, here, now, in this moment of letting go, here where the day ends and the night begins, here where consciousness fades and dreams emerge, here in the soft space between waking and sleeping, where everything is possible and nothing is required. Let the clouds carry you now. Let them lift you gently and bear you away to wherever sleep lives, to whatever country dreams inhabit. Trust them to hold you safely through the night, to shelter you from the stars, to wrap you in their softness. You are cloud and water, breath and stillness, thought and emptiness. You are drifting and you are still. You are here and you are nowhere. You are falling into sleep like rain falling from a cloud, inevitable and gentle, returning to the earth after a long journey through the sky. Fall softly, fall completely. Let go of the last thread of awareness and sink down, down into the deep quiet where nothing stirs and nothing disturbs, down where the body rests fully and the mind grows still, down where dreams wait with open arms and sleep wraps around you like the softest cloud that ever drifted through a summer sky. The journey is over now. The facts have been told. The clouds have shared their secrets. And you, gentle listener, have traveled far tonight, from ground to sky, from droplet to storm, from ancient ice to morning mist. You've seen wonders and learned mysteries, and now it's time to rest. So sleep now. Sleep deep and dreamless, or dream of clouds if you wish. Dream of floating through soft grey mist. Dream of standing on a mountaintop as clouds roll past at eye level. Dream of lying in a field and watching the sky slowly change. Clouds building and dissolving. Light and shadow playing across the land. Or dream of nothing at all. Let sleep take you to the place beyond images, beyond thoughts, beyond words. Let it carry you to the deep stillness at the center of all things, where clouds are born from silence and return to silence, where water becomes vapor, becomes cloud, becomes rain, becomes river, becomes ocean, becomes vapor again, endlessly, peacefully, without question or doubt. You are safe. You are held. You are exactly where you need to be. Good night, dear traveler. May your sleep be as peaceful as morning fog, as gentle as falling snow, as deep as the ocean from which all clouds rise. May you rest in the knowledge that you are part of something vast and beautiful, something that was here long before you and will be here long after, something that asks nothing but offers everything. The patient, endless, life-giving dance of clouds across the sky. Sleep well, sleep deeply. The clouds will still be there when you wake, drifting quietly overhead, waiting to begin their stories again. But for now, they whisper only one word, soft as mist, gentle as rain, constant as the turning of water through the world. Rest. Thank you for drifting through the clouds with us tonight. If you found peace in these floating facts, consider subscribing to Midnight Science for more gentle journeys into wonder. The sky is always waiting, always changing, always ready to teach us how to let go. Until next time, sleep well.